all over 10. Therefore, capital E is equals to 1.5 times 13 all over 10, which gives us 1.95 volts. Alternatively, electromotive force E, capital E, is equals to capital V plus capital I times small r, which is equals to, substituting the values, we have 1.5 for the capital V plus I is 0.15 times 3, which is equals to 1.5 plus 0.45, which will give us 1.95 volts. Cells in series. If three cells of EMFs E1, E2, E3 and internal resistances R1, R2, R3 resistance assist one another, then total EMF is equals to E1 plus E2 plus E3. Total internal resistance is equals to R1 plus R2 plus R3. Cell in parallel. For a cell in parallel, we have that the I1 total EMF is equals to EMF of one cell. 2. Total internal resistance R is that of the three resistance each in parallel. Example 3. Two cells each having an EMF of 1.5 volts and an internal resistance of 20 ohms are connected in parallel. Find the current when the cells are connected to a 11 ohms resistor. Solution. Total internal resistance in parallel is 1 over R equals to 1 over 2 plus 1 over 2, which is equals to 2 over 2, or R is equals to 1 ohms. Total resistance in the circuit is equals to 1 plus 11, which gives us 12 ohms. Total, from looking at figure 413, total EMF in parallel is equals to EMF in one cell is equals to 1.5 volts. From Ohm's law, I is equals to V over R, which is equals to 1.5 over 12, which is equals to 3 over 24 to give us 1 over 8 ampere. Series and parallel circuits. Looking at figure 414 example, what is the resistance of the circuit shown in figure 414? Solution. Combined resistance capital R in parallel is 1 over capital R is equals to 1 over 2 plus 1 over 2, which is equals to 2 over 2, or capital R is equals to R. Combined resistance in series is R equals to 1 plus 3 plus 4, which is equals to 8 ohms. Example 2. In figure 4.15, calculate the I total resistance capital R, II potential difference capital V across resistor 2 and 4 ohms, III current in each resistor. Solution. I combined resistance in parallel is given by 1 over capital R is equals to 1 over 2 plus 1 over 4, which is equals to 4 over 3 over 4. R, capital R, is equals to 4 over 3, which is equals to 1.33 ohms. II, capital V, equals to IR, which is equals to 4 times 1.33, which will give us 5.32 volts. III, current I in 2 ohm wire is given by I equals to V, capital V over capital R, which equals to 5.32 over 2, which is equals to 2.7 amps. Current I in 4 ohms wire, I is equals to 4.32 over 4, which is give us 1.3 amps. Total current flowing in the circuit is equals to I1 plus I2. which is equals to 2.7 plus 1.3, which gives us 4 amps. Question 3. Figure 416 resistor is in series. I. Calculate the total resistance R, capital R. II. Calculate the current flowing in capital R. III. Calculate the potential difference across each resistor. Solution. I. Combined resistance capital R in series is given by capital R equals to R1 plus R2. Therefore, capital R is equals to 8 plus 2, which is equals to 10 ohms. II. Current flowing across capital R is capital I is equals to capital V over capital R, which is equals to 2 over 10. It will give us 0.2 amps. III. The potential difference across 8 ohms wire is given by capital V1 equals to capital I arrow 1, which is by substituting the values we now have 0.2 times 8, which will give us 1.6 volts. Similarly, the potential difference across 2 ohms wire is given by V2 equals to I arrow 2, which is equals to 0.2 times 2, which will give us 0.4 volts. Total potential difference 1.6 volts plus 0.4 volts will give us 2 volts. Question 4. A voltmeter is connected in parallel with a variable resistance capital R, which is in series with an ammeter and a cell. The cell of EMF capital E and internal resistance small r for one value capital R1 of variable resistance. The ammeter reads 0.3 amps and the voltmeter reads 0.9 volts. For another value R2 of the variable resistance, the ammeter reads 0.25 amps and the voltmeter reads 1.0 volts. Neglecting the resistance of the meter, find the value of R1, R2, E, capital E, and the small r. Solution. From the equation, capital E minus capital I times small r equals to capital V. Substituting the values, we have that capital E minus 0.3 for the I times R is equals to 0.9 for the V, which is our equation 1. For the second circuit, we have capital E minus 0.25 R times small r, which is equals to 1.0 for the capital V, which is our equation 2. Making capital E the subject of the formula for equation 1 and 2, we have for equation 1 it will become E is equals to 0.3 R plus 0.9. This will be our equation 3. Then for equation 2, capital E is equals to 0.25 times small r plus 10. This will be our equation 4. Since the E's are the same, equating both equation 3 and 4, since they have the same electromagnetic force, we now have 0.3 r plus 0.9 is equals to 0.25 times small r plus 1.0. Then collecting like terms together, we have that 0.3 r minus 0.25 r is equals to 1.0 minus 0.9. Then which we now have 0.